All right, so today we're doing Piecewise Functions, 4-7, page 222, 1 through 22 on in the Big Ideas book. Each of these links underneath are links to videos that will help you to understand. The first one is Virtual Nerd, and the second one is really good videos, but they're longer. They're by eMath Instruction. Oh, yeah, I'm sorry. It is all. It's 1 through 22. All.
I mean, you could do 1 to 22.
No, it's all. Okay, here we go. So, the only way to hit the hyperlinks is you have to go in play mode. Now, the first thing we just read was, what is a piecewise function? Piecewise function is defined by 2 or more equations. Each piece of a function applies to a different part of its domain. So, what this means is that when you have the f of x, that's really your y. This means y equals x minus 2 only when the domain x is less than or equal to 0. If the domain is greater than or equal to 0, I use the other function. The f of x equals 2x plus 1. Remember, the f of x is really just your fancy y. So the way we read that is the f of x equals x minus 2 if x is less than 0. Or the f of x equals 2x plus 1 if x is greater than 0. All right. So here's how we're going to see it in our book tonight. Yes?
Can you go back one page and finish copying the example?
Okay. So here's how we're going to see it in the book tonight. So you'll notice that there are directions that say evaluate the function f when x equals 0. So when x equals 0, I'm writing it on the board, but you can't see it in the video. X equals 0. Go to your domain where it's showing the restrictions. You guys remember in Desmos, right? Yeah. Where it showed the restrictions. Which restriction does 0, when x equals 0, fit into? The first one or the second one?
First one.
Annabella?
The first one?
It's the first one, right? X, when x is 0, 0 is less than or equal to 0. So if that's the case and x equals 0, I'm using this function equation. Okay? Because that's the function that goes with x equals 0. So I'm going to end up using the original one, which was x is less than or equals 0, goes with f of x equals x minus 2. Now, what are they telling me to do with that 0 when x equals? It says evaluate when x equals 0. Luca?
Replace the x with 0 or substitute the 0 for the x.
Right, we're going to substitute the 0 for the x. So I'm going to do this. The f of 0 equals 0 minus 2. Okay? What are we doing next, please? Preston.
Subtracting 0 and 2. So
And how's it going to read?
f of 0 equals negative 2.
F of 0 equals negative 2. Now, what ordered pair is this when I'm done? Although this is the answer, I want to know what ordered pair is this? Sierra.
Negative 2, 0.
Uh-oh. Be careful. Remember, what is this? Follow your line of thought up. It's x. So, what is my x? 0, comma.
Oh, negative 2.
So, remember, when you get the f of 0 equals negative 2, that's as good as saying y equals negative 2. Remember, f of x really is the fancy way to write the y. So y equals negative 2. So that point would be, when it says the f of 0, 0 is your x. Does that make sense? Now, they're not writing that on the video, but I'm writing that on the board. The next problem is asking us to evaluate part B when x equals 4. So when x equals 4, which domain restriction am I using, Hershey?
X is greater than 0.
X is greater than 0. So when I have x is greater than 0, I'm going to use which equation? Hershey?
2x plus 1.
F of, read the whole,
F of x equals 2x plus 1.
2x plus 1. I'm using the 2x plus 1. Now what would I do? Arden?
Substitute the 4 for the x.
Good. The f of 4 equals?
2 times 4 plus 1.
Good. And now what am I doing? Simplify. Keep going.
Solving or simplifying, so you get 8 plus 1.
Which is finally?
That f of 4 is 9.
Okay. Now, although this is my answer for evaluating, what would that ordered pair be, Arden?
4, 9.
Perfect. It would be 4, 9. Are you with me? Okay. Questions? Yes.
So is the x minus 2 and
Okay, so a question was asked, are these two equations the only equations that are used? No, this is just for this scenario. Let's actually look here, just for this graph. For this graph here with this line here and this line here. Okay? Yes?
It's not always going to be 2x plus 1.
No, only for this graph. Because 2x plus 1 represents this piece, and x minus 2 represents this piece, with those domain restrictions. Okay? Recording. Okay, so here's what we are going to do. For the homework, you're going to see it like this. My first question is for number 1, which domain restriction will I use when we're looking at the function of negative 8? Ryan.
you would use f of x equals 3.
Why are you choosing the f of x equals 3?
Well, it's because the restriction for that is if x is less than negative 2 and negative 8 is less than negative 2.
Right, so if I substitute it in here, into this, I'm just going to repeat what he just said. If I just substitute that negative 8 in for x, and it makes it a true statement when I fill it in here for this x. Negative 8 is not less than 5. It doesn't work on the second one, and it doesn't work, negative 8 doesn't work here. So the only one it works for is the first restriction, and the first restriction goes with this. So when when we're talking about the f of negative 8 equals 3, is there anything to do there? Ryan?
Well, no, there is.
So all we're doing is, what they're saying, when x is negative 8, my y is 3. So I'm done here. But if I needed the point, what would that point be? Naomi?
Negative 8, 3.
Good. So for graphing purposes, if I needed to graph it, that's what it would be. But this is the answer. So I do the next one. Which domain does number 2 fit under? Domain restriction, I should say. Luca.
For x plus 2.
Okay, for x plus 2. So I'm doing x plus 2 because negative 2 is between or equal to negative 2 and 5. It fits in there. It's not greater than 5. It's not less than negative 2, but it's equal to. And since we have that greater than or equal to, so I would use the f of x equals that middle one I'm using now because it fits this domain restriction. So I get the f of x is x plus 2. The f of negative 2 equals negative 2 plus 2. So the f of negative 2 equals 0. So what ordered pair would that be, please? Someone I haven't heard from. Ethan, up front. What ordered pair would that be?
That would be negative 2, 0.
Perfect. Questions? Which domain am I going to use for number 6, Jake?
Number 6.
Domain restriction.
X is greater
greater than 5.
Do you guys understand what to do here? Yes.
So that's like -2r on the board.
Okay. Do you understand what to do?
Can you just go over how we solve number 6?
Sure. So in this case, let me just erase everything. Get a clean. Which domain restriction, Shaylin, will satisfy when x is 10?
X is greater than 5.
So because this is the domain restriction, I have to use this equation. So because we're looking at the f of 10, I'm going to use the f of x equals 4x. And then because it's 10, I have to go with the equation that matches that domain restriction. I just look straight to the left. Okay? So now I'm doing the f of 10 equals 4 times 10. And the f of 10, that's supposed to be a 10, equals 40. What ordered pair would that be, Shaylin?
It'd be 10 and
10 comma 40. Yes, Preston, question?
No, I was going to answer though.
Okay, yes.
do you want to strike the ordered pair?
Only for later, not for now. When it says evaluate, this is your answer. Okay? All right, now we're going to jump into a virtual nerd video where we learn to graph the function in a piecewise function. I like it because they show intervals. I want you to notice that. You don't necessarily need to draw the dashed lines with the intervals, but I think they give a good visual representation. So, you can either go to the beginning link and come back here, but I will play the video and show it here. Please take notes. This is piecewise function.
Graph a piecewise function. Here we have a piecewise function that has 3 different definitions. That means when we graph our function, we're going to need to graph all 3 of these pieces. We're going to graph f of x is equal to 2x minus 2 for x values less than 0. We're going to graph f of x is equal to -1 for x values greater than or equal to 0 but less than 3. And lastly, we're going to graph f of x is equal to -4x plus 16 for x values greater than or equal to 3. Since where we graph each piece depends on the value for x, let's begin by breaking these up into intervals. And we can draw these intervals on our graph. For x values less than 0, let's call this interval A. For x greater than or equal to 0 but less than 3, let's call it interval B. And for x greater than or equal to 3, let's call that interval C. Now let's go ahead and draw these on our graph. Our first interval is x.
What she means by intervals are areas. These are different areas, right? Interval is between this section and this section. So if I'm making a graph and I make an interval is an area. Okay, yes?
Should we do the graph?
I mean, you're probably going to need to.
Okay.
Yeah.
Less than 0. So, here's a line at x equal to 0. We want any value less than 0. This is interval A. Interval B is x greater than or equal to 0, but less than 3.
Hold on. Do you guys understand why it's interval A?
No.
Interval B is x greater than or equal to is x less than 0. So, here.
Look at this. My x is everything less of the 0 on the x-axis, which is here. Are you with me? So what they're talking about is the domain all this way. That's interval A. From here over. From the y-axis to the left. Okay, that's interval A. The next one says interval B. It's between 0 on the x-axis and 3. Do you see where 3 is on that x-axis? So that's where I'm going to put my dashed line through the 3.
The line at x equal to 0. We want any value less than 0. This is interval A. Interval B is x greater than or equal to 0, but less than 3. So let's go ahead and draw a dotted line at x equal to 3. This interval in here is interval B. And lastly, for x values greater than or equal to 3, this is interval C. Now that we have our intervals marked on our graph, let's go ahead and begin.
So, when we have 2x plus minus 2, you will only see that equation, a piece of that equation. You will only see it in interval A because you're only allowed to see that equation where x is less than 0, any of these. When I see equation B in interval B, you will only see it in this area. And when I see in the middle area under B on the graph, when I see equation C, negative 4x plus 16, we will only see that right here. So there's equation C. This would be equation B. You will only see it in here. And the third, oh no, of course it's not writing now. Okay, well, in the middle I can't draw it. It's all of a sudden not working.
By first taking a look at interval A. The function f of x is equal to 2x minus 2. Here, we're just trying to graph a linear function. To graph this linear function, we could use the slope and the y-intercept, and we could graph it that way. Or we could pick points. Let's go ahead and pick points. If we want to know what values for x to try, we can try any x values we want, and we can find the value of y. But we might as well pick points within our interval or on our endpoints, since we're only going to be graphing on interval A, for x less than 0. So let's go ahead and pick something less than 0. Let's go ahead and pick negative 2. If x is equal to negative 2, well then y is equal to 2 times negative 2 minus 2. So f of negative 2 then is equal to negative 4 minus 2. That means f of negative 2 is equal to negative 6. So we need to graph the point negative 2, comma, negative 6. Well, negative 2, negative 6 is the point right here.
Okay, do you understand?
0 is one of our...
Do you understand why she chose negative 2? Yes.
I have a question. Why did you put the A up there instead of below?
Because she's just saying everything this side of it is for this equation.
So it can't.
It doesn't matter where the A is. You don't even need to do this later.
Okay.
Okay?
But why did you choose negative 2?
Okay, she's choosing negative 2 because in the first equation for A, she just needs to pick anything less than 0.
Oh, okay.
You got to go with this restriction. The first point you're going to pick is going to be based on, it can be anything. The other point you're going to pick is going to be your boundary point. I have to pick 0. But notice, 0 is not included. 0 is not included in the line. But I have to still use that as my boundary point. So how might I show that? If I want it there to be a boundary point but not included. What?
You have to choose a negative number.
No, I'm using 0. Okay, well, let's look. Think about your inequalities. This is an inequality. How do I show that it's a boundary but not included in an inequality on a graph? Annabella?
Would you do the open circle?
Open circle. I'm starting it there. Okay, let's watch what she does.
Point. Let's go ahead and pick 0. Since 0 is not included, we're going to have an open circle at 0, since we have x less than 0. So we can pick 0, but we need to put an open circle at 0. F of 0 is 2 times 0 minus 2. Well, that means f of 0 is equal to 0 minus 2. So f of 0 is equal to negative 2. We need to graph the point then 0, comma, negative 2. And again, we said at this point there will be an open circle since 0 is not included in this interval. So, at 0, negative 2, there's an open circle. We can connect and we get this line right here. Again, this is for all x values less than 0.
Now, remember we said all x values less than 0. So it can only be seen from here over. I can't use any of these x's. Do you understand? Yes.
I'm just a bit confused on to why she did the second part of it. I get the first part with -2 and -6, but why?
The question was, why did she pick that second point and do that second part? Because 2 points make a line. So you need a second point. Now, yes, we could have graphed this with mx plus b, but you're going to need to remember where your boundary is. I actually like utilizing this as a boundary and finding 2 points. Okay? I like the way they're doing just picking 2 points. Let's keep going. Now we're going to go to interval B. In this one, how many boundaries do we have? 2 boundaries. What kind of line is this? F of x equals -1. Close. F of x, remember, that's like saying y equals -1. Right, it's a horizontal line. But I'm only having a horizontal line between these places on my x, for my x values. So, we'll watch her now.
So we put an arrow down and to the left. Now let's go ahead and take a look at interval B. If we take a look at interval B, in interval B, x is greater than or equal to 0, but less than 3. Take a look at the function. F of x is equal to -1. Here we have a constant function. F of x is equal to -1. To graph this function, we just need to graph a straight line at y equal to -1. Take a look at our endpoints. Here, it's x greater.
Okay, now remember, if I'm going to use 0, I'm writing, oh my God, are you kidding me? I'm going to use the f of 0. Oh my God, really?
Try using your fingers.
It's not that, because it's writing here. It's just,
Can you use one of those marker markers?
no, because that's not
Then
set up
or
right now.
equal to 0. That means 0 is included. So we need a closed circle at 0. Less than 3. That means 3 is not included. So we need an open circle at 3. So we want a straight line at y equal to -1 with a closed circle at 0 and an open circle at 3. So let's go ahead and draw that.
So, listen, we're going to finish this, especially because I'm recording. So, the ordered pair for 1 is going to be what? No, okay, closed circle, but what's the ordered pair? Yes.
I believe 0, -1,
0, -1. So, in this one,
and 3, and 3.
okay, so on the first one, I'm going to do the f of 0 as my boundary, equals -1. So this is going to be 0, -1. And the other boundary I need is the f of 3 equals -1. So I'm doing 3, -1. Do you understand where I'm getting those values from? Okay, let's go.
We have a closed circle when x is equal to 0. Straight line and an open circle when x is equal to 3. So now that we know what interval B looks like, let's go ahead and take a look at the last interval, interval C. In interval C, x is greater than or equal to 3. The function is f of x is equal to -4x plus 16. Here we have another linear function. Now we could go ahead and we could find the slope and y-intercept, or we could pick points. Let's go ahead and pick points to graph this function. Again, we can pick any x values we want, but we might as well pick x values within our interval, or at our endpoints. Let's begin by looking at the endpoint, when x is equal to 3. Here, the endpoint is included, so we're going to have a closed circle when x is equal to 3. So, if we want to know the y value, f of 3 is equal to -4 times 3 plus 16. Well, that means f of 3 is equal to -12 plus 16. So f of 3 is equal to 4. So we need to graph the point
Is that
3.
a boundary point or not?
Yeah.
So 3,
Yep.
4 is right here. And again, we have a closed circle at this point. Let's go ahead and pick another x value. Let's pick x equal to 5. So if x is equal to 5, then f of 5 is equal to negative 4 times 5 plus 16. Negative 4 times 5 is negative 20. So f of 5 is equal to negative 20 plus 16. Well, negative 20 plus 16 is equal to negative 4. That means f of 5 is equal to negative 4. So we need to graph the point 5, comma, negative 4. So 5 down to negative 4, we have a point right here. So this portion of the graph looks something like this. And again, we have an arrow because this is for x values greater than or equal to 3. Now take a look at our piecewise function. Here's the graph of our piecewise function. We have a function because it passes the vertical line test. If we take a look when x is equal to 0. At x equal to 0, we have an open circle at negative 2 and a closed circle at negative 1. That means when x is equal to 0, we just have one y value, negative 1.
So it is a
X is
function.
equal to 3, we have an open circle at negative 1 and a closed circle at 4. That means the y value at x equal to 3 is equal to 4. So we have a function. So now we know how to graph a piecewise function.
Okay.